Question 1.
For question 1, a password contains exactly 4 letters. How many passwords are possible if letters cannot be used more than once? So let's start by identifying R and N. R is going to be our number of letters. N is the total number of possibilities. So N is equal to 26, which is the number of letters in the alphabet. In this question, order matters. So we're going to be using a permutation formula. The number of permutations of R is written as n factorial over n minus R factorial. So we're going to substitute 26 for n. That's 26 factorial over n minus R, 26 minus 4 factorial. So we'll simplify that. That's 26 factorial over 26 minus 4 is 22 factorial. Now, if you're doing it by hand, we'll write it out this way. 26 multiplied by 25 times 24 times 23 times 22 factorial. I'll stop right there because we have 22 factorial on the bottom. So I'll cancel here. You can write that out if you would like to, but this is just a shorter way to cancel. So we have left 26 times 25 times 24 times 23, and that will equal to 358,800. You can also use Desmos or a scientific calculator and use your permutation formula. In this question, order matters. How many ways can a cook arrange 8 of 15 spice jars on a spice rack? So this is going to be a permutation. N is 15, R is 8. So we're going to use our permutation formula. 15 permutations of 8. It can be written this way: n factorial over n minus R factorial. If we write it out, it's 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7, and I'll stop at 7 factorial because 15 minus 8 is 7. So our numerator is written out. Our denominator is 7 factorial. The 7 factorial will cancel, and we'll multiply 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8. You can also use your calculator in Desmos or your scientific calculator.
Plugging those numbers into your calculator, you'll get 259,459,000 200.